Nope, but now it's recording. Okay. And we're going to do 32 and 64. So everything that gets turned on, we actually perform the math. And of course, we can see the math being performed down here at the bottom. So we're adding the 2, the 4, the 32, and the 64 together, and that's going to give us 102. So our decimal number that's equivalent to the binary number in this case is going to be 102. And that stands to reason in math the numbers have to make sense. Okay, because decimal numbers involve more digits, it's going to have a smaller value than binary numbers. Okay, so anytime we're converting from binary to decimal, we should have a smaller number. If we come up with a larger number, that's how we know that our answer is not correct. Okay, and so here's another binary number that we're going to convert to a decimal number. Once again, the zeros are off and the ones are on. Okay, and so we can see that 2 to the first power, 2 to the second power, 2 to the fourth power, and 2 to the fifth power are turned on. And that means we'll perform our calculations with those numbers. And we have 32 plus 16 plus 4 plus 2. Add it together and we'll equal 54. Okay, and here's another one. Okay, in this case, we're going to take the decimal number of 52 and we're going to express it as a binary number. Okay, the process that we just completed where we added together to find the decimal number, we'll reverse that process to find the binary number. So where we added to find the decimal, to go back from decimal to binary, we'll subtract. Okay, so processes can always be reversed in order to convert backwards and forwards. Okay, in this case, we're going to use our binary place value chart again. And so we're going to look for the highest power of 2 that is not greater than 52. Okay, so we can't use 64 because 64 is clearly 2 to the 6th power equals 64 is clearly greater than 52. So what we'll do is we'll use 32. Okay, so we look at 32. 32 minus, when we take 32 away from 52, we have 20. And then we'll say, well, okay, the next one we can use is 2 to the 4th power. And 2 to the 4th power is 16. So we take 16 away from 20. We'll have 4. And then finally, we'll move to 2 to the 2nd power, which will equal 4. We can't use 2 to the 3rd power because 2 to the 3rd power equals 8. And we can't take 8 away from 4. That's a much larger number. Okay. And so if we add up 32, 16, and 4, we come back up with 52. Okay, does anyone have any questions about what I just did? No, yes? Okay, here's your chance. Okay, here we have the decimal number 132, and here's your binary table. I want you guys to convert 132 to a binary number. Okay, let's see. Thank you, Charity. Thank you, Jamar. Okay, let's see. Okay, Randy, what did you come up with? Okay, great. Thank you. And thank you, Leonard. Okay, so let's look at this. The first place value we can look at is if we got 132. Okay, we're going to start with the highest place value that we could take up out of this, which is going to be 128. Okay, so we can see that we can clearly subtract 128 from 132. And so that's where we're going to put our first one at. Okay, so we're going to put a 1 right here. Okay, because we can see that we can take 128 from 132. Now, if we couldn't take 128 from 132, we would skip that place value. That means that it would be off. Okay. Now, once we subtract the 128 from 132 down here, that's going to leave us with 4. So we have to skip all of these. And the next place value we can use is the 4's place value, where 2 to the second power equals 4. Okay. And then that leaves us to 0. And of course, we can see that here. And then all that gets cleaned out too, because we can't do anything with it. Okay, so looks like everybody came up with the right answer on this one. Okay. All right, let's see if you guys can do this one right here. Take the decimal number 12 and convert it to a binary value. The place value chart, yeah. Okay, here's the place value chart. You know, you guys could actually create that place value chart yourself just by going 2 to the 0 power, 2 to the first power, 2 to the second, and then putting in the values. Or you can screenshot it, and then that way you'll have it when you're working on it in Alex. Okay, thank you, Randy. And Charity, thank you. Okay, how's everybody else coming along? Okay, thank you, Jamar and Leonard. Okay, so let's look at this. Okay, there's quite a few of these place values we're going to have to pass by simply because we can't take them from 12. Okay, you can't take 128, 64, 32, or 16 away from 12. Okay, so the first place value that we can actually take from 12 is where the 8 is. Next place value will be 4. And then, of course, that leaves us with nothing left because 8 plus 4 is 12. Okay, so you guys were excellent. You did a good job converting from a decimal number to a binary number. Okay, and moving along, we're going to look at hexadecimal numbers next. Converting to hexadecimal numbers. Okay, hexadecimal numbers has 16 digits. So that means that it's going to have a base of 16. Wow, now we don't actually have 16 digits in our number system. So that means we got to use some letters. Okay, in order to convert from binary numbers to decimal equivalents, we have to split the bits into nibbles and then find the hexadecimal equivalent of each nibble. Okay, so here we go. Here's the place values for our hexadecimals. Okay, and so what we're going to do is we're going to take uh, this right here, 8 bits, and we're going to split it into 4 nibbles. And so we can see it being divided. And, we'll look at the left side and the right side separately. Okay, we're going to use our binary number place value chart. Okay, every place that is on, okay, we'll do calculations. Every one that's off, we'll ignore. Okay, and so we are going to have 2 to the third is on, 2 squared is on, okay, and 2 to the 0 power is on for the left side. For the right side, we have 2 to the second power, 2 to the first power, and 2 to the 0 power is on. So we'll add up those numbers. 8 plus 4 plus 1 equals 13. And 13 is going to be D. And then we have 4 plus 2 plus 1 equals 7. And of course, 7 will be the digit 7. So our final answer is going to be D to the 7th power. Okay, and that's how we convert a binary number to a hexadecimal number. Okay, that's probably a good idea to have that place value chart for your hexadecimal numbers. Okay, there's a saying, there's only 10 kind of people in the world, those who understand binary numbers and those who don't. Okay, somebody's got some stuff going on. Alrighty, applications. Okay, that's why we do math. It's for the applications, to be able to apply it to the real world. Math is just a tool that we use to make better decisions. Okay, it allows us to be exact instead of estimating or guesstimating or rounding. At some point in time, we have to know specifically what is the value of something. Okay, a good example would be our paycheck. We don't want anybody estimating or guesstimating our paycheck. We want to know exactly what our paycheck is. Okay, so the first place we're going to start is right here with percents. Okay, here's an example of an application of multiplying percents together. If a musician gets a royalty payment of 10% of the CD sales receipts, but has an agent who gets 15%, what does the musician get? What is the agent's rate of the total CD sales? Okay, so we're going to look for certain words that are going to let us know what operation to perform. Okay, of course, we got 10% of 15%. Now, everything else is just to give us a point of reference and This kind of let us know what's going on with the musician's royalties. Okay, the only thing that we really need for the math is the percentages and the word of. Okay, the numbers will always be easy to identify. It's the operations that are going to be challenging. What buzzwords or what key words let us know that we should be adding, multiplying, dividing, or subtracting? And at the end of the day, those are the four things that we do in math. Okay, so when we look at this problem, the word of is telling us that we need to multiply because that's what the word of means. It means to multiply. So we're going to take 10% of 15%, which is going to be 10 times 10% times 15%. Uh, we can't perform any math with percentages. Okay, so we'll have to convert the percentages to decimals or fractions. In this case, it's probably easier to convert them to decimals. So in order to convert a percent to decimal, we simply move the decimal point from the far right to the left, 2 places. And when we do that, that's going to give us 0.15 and 0.10. Once we do the multiplication, our answer will be 0.015, which is 1.5%. Okay, so that's what percentage of the total sales the musician gets, the agent gets of the royalties, 1.5. Okay, here's another problem. A department store sent out a flyer that they would give a discount of 50% on certain items already discounted. If the original discount was 50%, what is the actual discount now? Okay, discount problems come with a formula, and so it's kind of remember it's good to remember that. Okay, part of it. Okay, I'm going to give it to you because these are really amount, base times rate times amount. And so it doesn't matter whether it's a discount, whether it's taxes, whether it's interest. They all use the same framework or the same formula. Okay, and the way that works is we say the base times the rate equals the amount. Okay, now the base could be principal, the rate could be an interest rate, and then when you multiply those together, it will equal the amount interest. Okay, the base could be uh, an item purchased. The rate could be a tax rate, and when you multiply those together, it'll give you the taxes. Okay, the base could be, regarding a sales item. Okay, and the rate could be a discount rate. Okay, and when you multiply that together, it'll give you the discount amount. Okay, so regardless to what we're working with, okay, with these types of percentages, the concept is always the base times the rate equals the amount. And the base is always the largest number. Okay, the rate will be a percentage or a decimal. Okay, and the amount will be, okay, it'll be similar. Like if you got a discount rate, you'll get a discount. If you got a tax rate, you'll get tax. If you got what else can we get? An interest rate, you'll get interest. So the amount will always have a similar name as the rate. Okay, so that's the way it works. Okay, so in this case, we already got a 50% discount. Okay, and so what we're going to do is we've got an original discount. We're going to turn around and add that to a new discount. Okay, so original plus new equals the total discount because you're getting two discounts here. So that's the way we're going to do it. The original plus the new equals the total. Okay. Now, what I'm doing now is a process that, you learned about, I want to say during week 6, where we talk about like day 6, when we talk about word problems. And we said that you need to either draw pictures or create labels. Okay. So that's a concept that we talked about, drawing pictures and creating labels. Okay, so we draw pictures and create labels to give us a point of reference to help us to understand exactly what things we're supposed to bring together and how it's supposed to look. Okay, so that framework is going to give me a good understanding. And this is just getting my thoughts together. That's all this table, okay, or this labeling is doing for me. It's allowing me to, commit my thoughts to paper, which is something that, that's a critical thinking skill that we should be, utilizing in everything we do, not just math. Okay. So the original amount was 50%. That's the original discount. So I know that when I'm finished, the discount that I'm going to get is going to be more than 50% because I'm going to get the original discount of 50% plus I'm going to get the new discount. Now with the new discount, that's going to be the base times the rate, whatever the base was. Okay, the base in this case is going to be 50%. And then the rate is going to be the discount rate of 50%. So I've got 50% of 50%. Okay, 50% of 50%. And I'm just going to put the words in for now because the thing is I want the answer, but I also want the process too, because the process is just allowing me to develop skills that I'll be able to use later on. Math is like building a house. Okay. The stuff that you learn now, if you learn it the right way, you'll be able to build an even bigger and better house later on. Okay. If you don't learn it the right way, if you put it together real quick and real fast, then when you get to more complex forms of math, a more higher, a more critical math concepts, it's gonna be challenging for you. Okay, not to say it can't be done, but it will be challenging. Okay, so I got 50% of 50%, which I now know that when I multiply that together, I'm gonna make 50%. I'm just convert it to a decimal now, and then here I got zero point 0.5 times zero point 0.5. Okay. And this framework right here with the table and all, I'm getting a chance to see, you know, all my thoughts are being organized. So, I'm performing these steps throughout this process, but I'm organizing my thoughts on how I want to solve this problem. Okay. Because there's the problem, then there's the steps, then there's the answer. Okay. So this part of it is really important for me so that, one, I come up with a good answer, but I also build a solid foundation, for math skills as I move forward. Okay, so I got zero point 0.5, and then zero point 0.5 times zero point 0.5 is going to give me 0.25. Okay, and then I'm going to add those two together, and that's going to give me 0.75. Okay, now technically I can leave the answer like that because the problem didn't tell me that I had to write my answer in percentage form. Okay, when they don't say, you could kind of leave it in decimal form if you choose to, but I'm going to convert it back by moving it 2 places to the right. Okay. These answers can be written in 3 different forms. They can be written in decimal form, percent form, and fraction form. And if I was writing it as a fraction, it would be 75 over 100 because percent means per 100. Okay. And all that does is just solidify my foundation and understanding of math. I think Albert Einstein said all things are relative. I mean, they really are. Everything's really interconnected. And so, building that point of reference and developing a framework that's going to help me when I move forward with more complex math concepts and skills is very important. Okay, because this is not the only math I'm going to be doing. Okay, and I know even in our class that the math is going to get more harder. And so if it's like building a house, if it's going to get more harder, then the easier stuff that I learned, I really need to know it inside out so that I can use the easier stuff to help me learn the harder stuff that's coming forward. Okay, so this has going to be 75%. Okay, so that's the discount. And 75% makes common sense because the original one was 50%. And so if I added a new discount to the original discount, it should be more than 50%. If I got something less than 50%, I know something's wrong because that was my original discount. Who's going to let you take, a discount off the table or reduce a discount, when you were supposed to be getting an additional discount added to the original discount? Okay, so nobody's going to do that. So that's how I know it makes common sense. And that's just my way of reasoning it out. Everybody has their own, way of reasoning it out. That's just making sure that the answer makes common sense. Okay, because if I can't reason the answer out, then it's kind of pointless. Because the idea behind the math is to make better decisions, not to just come up with an answer. Okay, and so let me clean this up. Now, I use tables, and that's what I recommend you use, tables and pictures to summarize your information. The more you do it, at some point in time, you'll be able to frame these pictures and tables in your mind, what you're looking for and how you should be solving the problem. Okay, so we added them together and we came with 75%. Okay, now here's another problem here. It says a pair of boots cost $40 after a reduction of 20%. What is the pair's original price? Okay, so what we do on this type of problem is we'll start off with, okay, we've got a base times a rate equals an amount. Okay, so that's the way we look at this problem. And then I'm going to put in the information that I know I already got. Okay, notice how I'm setting up. I'm using the formula like a table, and I'm just setting it up because I'm going to fill in what I got. Okay, I know what my rate is. My rate is 20%. Okay, and I know what my amount is. My amount is $40 because that's after the reduction. It didn't say, before the reduction. If it was before the reduction, that would be your base. But after the reduction means that, it's already been taken out. Okay. So, at this point, I can look at this and I can say, well, okay, how do I solve this problem? Here, I just treat it like it's a formula. Okay, to solve it. Okay. And so when I look at this, I say, well, okay, how do I do that? Okay. Well, what I'm going to do is I'm going to take my original price. I'm going to subtract my discount. And then that's going to give me my cost. Okay, so let's see. My cost is $40. My original price, I don't know, so I'm just going to call it X. And then I'm going to subtract the discount. The discount can be found by saying X times 0.2. Okay, 0, which is 20%. And that's going to equal 40. All right, so from here, when I look at this, I'm going to rewrite this as 1x minus 0.2x equals 40. And then that's going to give me 0.8x. And the way I came up with a 0.8, I just took $1 and I subtracted 20 cents from it, like that. And that's how I came up with the 80 cent. I'll put a 0 back here because that'll work out. And then I'll divide 0.8 from both sides. A 0.80. And then my final answer to work with a calculator will equal 50. Okay. Okay, so that's about right. Let's take this out right here. And if we put 50 here for my base, 50 times 20% will give me a discount of 10. And then if we take 50 minus 10, we come back up, which is our discount. We come back up with 40 bucks. Okay, so that's how we work it. So the base was 50 in this case. If we went back to our original one, we would have, 50 minus 50 times 50 minus 50 times 20% equals 40. Okay, and from there, that would give us 50 minus 10 equals 40. Okay, so we'll clean it up here. Okay, so here we go. Divide both sides by 0.8, and that gives us the 50. Okay, now I really like the tables or the labeling because you can really look and see, okay, I got my original price minus my discount, but how do I get to my discount? The discount is going to be the base times the rate equals the discount, right? Because the amount is the discount in that case. So that's the way you go about doing it. And that answer has to make sense. So if we actually took 20%, let's say if we took 20%, we took 40. Let me go back. Let's say we did this. Let's say we took 40 and multiplied it by 20%. Okay, that would give us 8. And we know the original price can't be $8. Okay, not if you're getting a discount and the price after the discount is 40, that price actually went up. So we know it couldn't be 8. Now if you took 40 and divided it by 20%, that would give you 200. And there's no way in the world a 20% discount off of $200 is going to leave you with 40 bucks. I mean, if that was happening, then all of those 25% discounts in the store off of 100 bucks, people would be walking out paying pennies for clothing items and stuff like that. So that doesn't make sense either. So dividing or multiplying by 20%, the answers just don't make sense. So we wouldn't want to do that. Okay. And if you were starting to do that, then you would look at it and say, that answer's not going to make sense. Let me try something different. Okay, because that's just not going to work. Okay, so here we have a markup. Okay, markup is where we increase the price of something. Okay, a markdown is where we take the price down. Okay, here, and so in order to mark something up, okay, now you could do that two ways. I want to show you both ways because the project problems where we were increasing by 24% was actually similar to a markup. Okay, that increase was an increase of a percentage rate. Okay, there's a longer way of doing it, and then there's a shorter way. Okay, and so if we're going to do this, we could say 82 like that times 0.43 like that. Then whatever we come up with, we could add it back to 82. So this could be one way of doing it. Okay, and it's going to give us the answer. Then I'm going to talk about the other way, and then I'll kind of tell you why. Because that's the most important thing. I mean, you can take the shortcuts and stuff, but it's important to know why they work. Okay, so that's going to give us 35.26. So that's obviously the markup right there. And then you're going to add that to the 82. Plus 82. And then that's going to give us 117.26. Okay, so that's one way of doing it. Now the other way of doing it is to take the 82 bucks and multiply it by 1.43. Then if we take 82 and multiply by 1.43, we're going to come up with $117.26 as well. Okay, so multiplying it by 1.43 is the faster way. Okay, now that where the difference is, okay, in the first one, let me change the colors here on these pens. I'm going to make it blue. In the first one, we multiplied by 0.43. In the second one, we multiplied by 1.43. Now, where that one came from, that one came from the 82. Okay, because 1 times 82 is 82. Okay, so that's where that 1 came from. So instead of adding the 82, we just went ahead and combined the 1 times 82, which is 82, and then the 0.43 times 82 in one multiplication problem. Okay, so both of these methods are really the same way. Okay, when we come back to our fundamental understanding of multiplication and addition, we all know that multiplication is just a shortcut for addition. So multiplication and addition are the same thing. The only difference between multiplication and addition is multiplication is just addition on steroids. Okay, so that's the way we look at it. And let's clean this up. Okay, there we go. There's 35.26. Add them together. There's 117.26. Now, back to our base. Okay, this is our base right here. That's our rate. And this is our amount. Okay, an amount can be discount, taxes, markup, what else? Interest. Okay, and then of course the rate is going to be named similar to the amount. If the amount is interest, then the rate is interest rate. If the amount is discount, then the rate is discount rate. If the amount is tax, then the rate is tax rate. Okay, so that's the way it works. But when you multiply the base times the rate, it gives you the amount. Okay, so that's always a fundamental concept. And with percentages, you know, we're going to always multiply and divide. We wouldn't be subtracting a percentage from a base or amount. Okay, so it'll always be multiplication or division. And that's half the battle because you kind of like subtract that fourth. You kind of like subtracted a bunch of stuff out to begin with. Okay, here's a markdown. Okay, now in the markdown here, there's not that much we have to do. Okay, to figure out the markdown dollars, okay, we're going to compare dollars to dollars. Okay, in this case. So when we look at this, we're going to say, well, okay, 70 minus 68. So that was a markdown of $2. Okay, because it went from 70 to 68, so it went down 2 units. And then to find the markdown percentage, we simply divide the markdown dollars by the original, and that gives us 2 divided by 70 gives us 0.02851. Move the decimal 2 places to the right, gives us 2.8571. Okay, we round it to the nearest hundredth place. It's not uncommon for us to round to the hundredth place value when we're working with decimals. And then we just slap a percentage sign on the back of it. And the reason why it's not uncommon for us to round to that place value is because we were working with money. The hundredth place value is where the pennies are. So that's very commonplace for us to round. And sometimes with other things, we'll do something different. Okay, here's business problems. Okay, now with business problems, I mean, we always want to look at the problem and see what they're asking us. So suppose Anna earns $42 a day, Brett earns $35 a day, Chris earns $51 a day, Donna earns $47 a day. What is the average they can earn each day? Okay, I know that the lowest amount is 35 bucks. So my answer can't go below 35 bucks. And the highest amount is $51. Okay, so whatever I come up with for an average is going to be between 35 bucks and 51 bucks because an average is a number that represents everybody. So it's not going to be outside of the data set, as we could say, or outside of the population. Okay, much like if we had to have or vote for a president, then for the United States, then he's got to represent the American people, so he's got to be American. Okay, you're not gonna allow somebody to be president of the United States who's gonna represent us who's not American. Okay, and so that's what the average or the mean is. So when you look at your grade, okay, that is a grade that represents all of your grades, not just one grade. So if you do really bad on one test, you don't have to feel like that's going to be what your grade in the class is because, if you've got a bunch of A's, the A's will drown out that F because the A's have say, just like that one F has say. Okay. And so that's how we look at averages. Okay. Just know that an average is a value that represents the entire group. Okay, much like if you guys were going to vote for a class president, everybody has some say on who the president of the class is going to be, and that person's going to represent the entire group. So one person may say, well, I didn't want that person for president. Well, that's too bad. You're not the entire group. Okay, you're just one person in the group. Okay, and so it doesn't work that way. And so in this case, this number is not going to represent one number. It's going to represent all the numbers, but it's going to be in between the lowest number and the highest number because it can't be outside the group. Okay. Now, why did I do that? Because that gives me a point of reference, So I know my answer's got to be in between 35 and 41 before I get started. So if I hit the wrong thing on my calculator, okay, or I added incorrectly, okay, just understanding this point of reference is going to let me know that I've done something wrong. I need to go back and work the problem again. Okay. And so the way I'm going to find is I'm going to add up all the numbers. And so that value that I'm putting there is called sigma. That's a Greek letter. It means summation. And so I'm saying the summation of all the numbers divided by the amount of numbers. So that's how I find the average or the mean. Okay. Now, those symbols that I just put up there for you, okay, those are going to be symbols that you're going to need to remember because you're going to see them again when we do statistics. So what I'm saying is you're going to take one x value and you're going to add up all the x values like that. Okay, plus, and move this out of the way, like that right there. Then they're going to get divided. So I'm saying since there's 3 there, I'm going to divide this by 3. Okay. Well, in our problem, there's 1, 2, 3. There's 4 numbers. So that's going to be 42 plus 35 plus 51 plus 47. And those 4 numbers are going to get added together and divided by 4. Like that. So we put them together. So we got 42 plus 35 plus 51 plus 47. That's going to be 175. And I know if I made a mistake on my calculator, which I'm pretty positive I didn't, but if I did, divided by 4, I would be able to make sense of my answer and I would know that answer is not right. So 175 divided by 4 gives me 43.75. And I'm going to put that 43.75 right here. Okay, and so 43.75 is in between 35 and 51. Okay, now this does not mean I'm right. Okay, but what it means is that I got a good chance of being right. Okay, if something went wrong otherwise, then. But I know the answer is not going to be like 60 or 70 or like 15 or 12. Okay. Um, what I'll probably do just to make sure is I'm going to go back and look at the values that I transferred because there's a type of error called transposing errors. It's where you transfer the data incorrectly. Okay. And then there's like calculating errors. It's where you simply added or subtracted incorrectly. There's a whole bunch of errors you can make in math. So you really want to double check your work and be careful. Okay. That old cliche, haste makes waste, is really true in math. Okay. If you're very fast and don't want to double check your work, okay, that's just a poor habit that's going to catch up with you later on in math. And also when you're making business decisions, too, you have to take your time and double check your work and make sure you're making the right decisions. So I'm adding these numbers up again because I don't like to be wrong. So when I added up 42, 35, 51, and 47, that gave me 175. And then I'm going to divide by 4. And then that gave me 43.75. So I've double checked my work. I came with the same answer twice. Okay, I feel pretty good about it. All right, there we go. And there we go. So that answer is 43.75. So we're correct. Our answer falls between 35 and 51, which is what it should do because it is an average. An average is a number that's supposed to represent the entire group. Okay, not just one person or one item in the group. It's supposed to represent the entire group. Okay, so that's it. All right, here we have another problem. Okay, these are best buys. Now, averages are important, okay, because they allow us to represent the entire group, but they also allow us to compare things too. Okay. If one student got a 80 average and another student got an 85 average, okay, what we're doing is we're able to compare those students' performance in the class. You can't just use like one test because one student could have got an A on one test and then flunked all the rest of the tests. And then another student could have, flunked that test that the other student got an A on and then passed all the other tests. So what we have to do is we have to look at an average to compare them. To say, well, okay, well, this is what you did overall, and then this is what you did overall, and this is what determines who performed better in the class. So we're going to do the same thing here. We've got two different things here. We've got a 12-ounce can, a 10-ounce can, and we want to really decide which buy is the better buy. Okay, you can't just look at the numbers. I remember I was in Winn-Dixie one time, and they said that they had some tilapia on sale, and I actually fell for it. So I said, well, I picked up the tilapia, and then I started thinking about it for a second. I said, wait a minute, let me see how much I'm actually going to save. So when I found the unit price, and the unit price is where you take the total dollar amount and divide it by the total quantity. In this case, it's going to be ounces. When I divided them, I found out that it wasn't on sale. That the smaller packages were actually the same unit price as the bigger packages. I'm like, well, I'm really not even getting a discount here. I thought I was getting a cheaper price per unit, but I'm paying the same thing. It was just a gimmick to get me to buy the larger items, which, sometimes you don't need all that extra stuff. I mean, sometimes we buy things because we think that we're getting a special. So since we're getting a bargain, then we'll say, well, I'll buy extra and then freeze it. Well, if I'm not really getting a bargain, there's no sense in me buying it. I could leave it where it's at, just get enough and save my money and spend it on something else. So that's what we're looking at here. Which buy is really the better buy, you know, per unit price. And so when we look at this, we're going to figure out what each unit price is. So we're going to take the $1.99, convert it to 199 cents, and then we're going to divide that by 12, and that's going to tell us that we're getting 17 cents. We're paying 17 cents for each ounce. And when we take the $1.79 divide it by 10, because that's the total quantity, we're going to see that we're paying 18 cents per ounce. Okay, so the better buy is the $1.99 can of mushrooms because we're only paying 17 cents, per ounce for it. It's cheaper. Okay, so here's another Best Buy. We have 3 ounces of salami, uh, and we want to know, is that the same weight as a quarter pound? Okay, so in order to do this problem, we got to know what the conversion rate is. Okay, unit rates are important to help us compare things that are different. Okay, so uh, how do they measure up against each other if they have the same, if what their unit rates are? Okay, and then conversion rates are rates that we use to convert something to something else. Okay, so like if we wanted to convert, say, pounds to ounces, we would have a conversion rate. Okay, and everything has a conversion rate. Okay, rates are consistent, so that's what makes them great. Okay, so in this case, we got to know that 16 ounces is equal to 1 pound. Okay, so the conversion rate is 16. Okay, so we're either going to divide by 16 or multiply by 16. So if we wanted to convert 0.25 pounds to ounces, we would say 16 times 0.25, and that would give us 4 ounces. Okay, if we wanted to convert ounces to pounds, then we would say 3 divided by 16. Okay, so our conversion rate in this case is 16. Okay, because it's a 16 to 1 ratio. Okay, so if you have one unit that's one and then the other one is another number, then you can simply use the number that's not 1 as your conversion rate. So we're going to either multiply by 16 or divide by 16, depending on which way we're going. Okay, so when we take 3 ounces divided by 16, that gives us 0.19 pounds. Okay, and 0.19 pounds is clearly not 0.25 pounds. So the conversion rate allowed us to convert the ounces to pounds, and then we can compare the two and see that they're not the same thing. Second way of doing it, we're going to take the 0.25 and multiply it by 16, and then that's going to give us 4 ounces. And so we can see that the quarter pound is equal to 4 ounces, which is not 3 ounces. So the answer is no, no, no. Okay. This is something that's important to remember because you're going to be converting things a lot. Like, we were dealing with the metric system. There are times we have to convert things when we're dealing with the customary system. There are times we have to convert things. So you're going to always be converting things, and just understanding what the conversion rates are is important. Okay. If you can't remember conversion rates, you can always Google it. Okay. You can go to Google and say, convert tablespoons to ounces. I do that a lot because I try to eat healthy. And so sometimes, I can't remember what the conversion rates are. And so I just put them into Google, and they'll pull up a calculator, a conversion rate calculator that'll show you how to convert from one to the next. But once I get the conversion rate, whatever it is, like there are 12 inches in a foot. So the conversion rate is 12. Okay. So if you've got like 52 feet, if you multiply it by 12, it'll give you the inches. If you got like 246 inches, if you divide it by 12, it'll give you the feet because the conversion rate is 12. Okay, so I'm going to always be working with dividing and multiplying by 12. Okay, so that's that. Okay, here's another application for math. Okay, and this is really a sales pitch to help you understand that math is important. Okay, we have to use it to make better decisions, and there's a lot of ways we can use math. Financially, health, um, in our occupation. Okay, completing tasks. Okay, you can use math for almost anything. Okay. Um, but a lot of times students ask, well, why do we need math? Well, this is where we show you. Okay. Okay. So here we got a situation, and it says Karen has a checking plus bank account that lets her overdraw on her account. Write checks for more money than there is in the account. Overdrawn money is noted with a minus sign. Karen starts out with $150 in her account. She takes out $100 from the cash machine twice. What is her account balance? Okay, so in this case, we'll be working with just basic, addition and subtraction or integers, negatives and positives. Okay, so she started with 150. She took out $100 twice. And that problem could be done two ways. I mean, that's one way of doing it. Okay, another way of doing it, we could just say 150 minus, if this twice 100, you could say like this right here. Okay. Then the order of operations demands that you do the multiplication first, minus 200. And then your final answer is negative 50. So you can't get away from that one. Okay. And so that you come up with the same answer either way. Okay. At the end of the day, the math concepts are like tools. They're like hammers and screwdrivers and wrenches and sockets. And that's what we basically teach in CMA and math class is how to use these tools. Then you take these tools into other classes and you build things with them. Okay, and so that's what it's like, much like a carpenter. A carpenter learns how to use a hammer for a reason. Okay, he doesn't use the hammer because that's his job to swing a hammer around. The hammer is used to build things, like chairs and benches and and boxes, wooden boxes and stuff like that. So the tool has a purpose. Okay, here's a really great commercial, well, a really great video I want us to watch. It's kind of funny, but it helps us out with understanding, you know, well, it's just funny. Okay, so I'm gonna play it. I can get it up and running. Okay, I'm gonna provide you guys with the link of it too in case it doesn't work out. Mm, okay, no fair. All right, here we go. And then you can play it along if it that's one. Okay, it's a commercial. Okay, so I'm gonna provide you with the link. So if you can't hear it, then you can go to the link yourself. Okay, that's a good icebreaker into our personal finance stuff. All right, so here we go. Looking at a checking account, you'll see a problem similar to this in Alex. Okay, Amy's checking account had $4,040.70 as her balance on May 18th. Okay, she's going to deposit some money, pay some money, deposit some more money, and then they're going to ask us to fill in the checkbook with these transactions. And then we got to make sure we update the balance as we go along. Okay, so we can see what her balance was of May 18th, right here, the 40,000. And it's supposed to let me write on it right here, so we can see the balance right there. Okay, and then now we can start see the transactions as they come in. So on May 19th, the deposit. Okay, now you want to make sure that you fill in all the numbers and even the dates and stuff, because if you don't fill it in correctly in Alex, it'll mark it wrong. Because the deposit gets added. Then there's this is another common mistake folks make. They don't put in the check number, and then it gets marked wrong for that as well. Put in the date, then the payment for the insurance. Then we subtract that out. Then we put in the date and the deposit. We add that amount. And so that's the balance. But we always make sure that we keep a running balance as we go along. Another business application that we'll come across is depreciation. Okay, with depreciation, what we're going to find is some key terms that we'll have to know, like salvage value or residual value. The salvage value or the residual value is what the asset is worth at the end of its useful life. Okay, so after you no longer can use it, what can you sell it for if you were selling it for junk? The estimated useful life is how long the item is expected to be used. Again, that's not how long it will last, but how long it's expected to be used. Accumulated depreciation, okay, that is the total of all depreciation expenses to date. Book value is the original cost minus the accumulated depreciation. Okay, and then we can figure out what the depreciation is by taking the cost, what we paid for it, subtract out the salvage value, and then divide it by the estimated useful life, and that'll tell us how much we can depreciate for each year. Okay, now we depreciate it each year because the IRS, when you're running a business, won't let you write off, an entire building or write off a large ticket item like a piece of equipment that first year. You have to write it off gradually over the useful life. And a lot of times they'll tell you, like, there's some assets that have like a 3-year or a 5-year useful life. Okay. Okay, so here we go. A Suburban Production Inc. purchased a delivery vehicle that cost $25,000. The delivery vehicle has an estimated useful life of 5 years and a residual value of $1,200. Okay, now for a delivery vehicle, that's what the IRS determines, because that 5 years is an accurate statement. The IRS determines that it's used for 5. So, they may use it for more than 5 years. They may use it for 20 years or may use it for 10 years. But the IRS says that you can write off the entire vehicle in 5 years. Okay. People want to write it off as fast as they can, especially if you're a corporation and you pay cash for it. Okay, because you're paying taxes on something and you've already spent the money on it. So it's not fair. All right, so here we go. We're going to use straight line method of depreciation. They have another method called the accelerated method, and then they have another one called modified accelerated cost recovery method as well. Okay, so we have annual depreciation expense, accumulated depreciation, and book value at year's end. So those are the things we're going to look at. Okay, so to figure out what the annual depreciation is, we're going to take the cost, subtract the residual value, and divide that by 5. So we're going to take 25,000 minus 1,200 divided by 5, and that'll tell us what our annual depreciation is. That'll tell us how much we can write off each year up into that 5th year. Okay, and so when we do that, we're going to come up with $4,760 we can write off. That means that we can say that we spent $4,760 of the purchase price of that vehicle each year. Okay, now what we'll do is we'll put that in. The accumulated depreciation for that first year is going to be the same as the annual depreciation. Okay, and then our book value will take our cost and subtract our accumulated depreciation from it. And then that'll give us 20,240. For year 2, the depreciation is going to be the same every year, so that's going to be 4,760 again. Okay, what depreciation is the same? Because it's straight line depreciation. So that means the depreciation does not change. It's the same every year. Even though we're putting the formula back up again. The accumulated depreciation is going to be more. Okay, we'll take the 4,760 and add and multiply it by 2 because we're in the second year. And then that'll give us accumulated depreciation. Okay, so we take the depreciation and multiply it by the year to get the accumulated depreciation. That's going to be 9,540. Okay, did I say 9,540? 9,520. Then we're going to take the 9,520, subtract the 25,000. It's going to give us 15,480. Okay, and so that was for 2 years. Okay, something else we'll see is taxes. Okay, there's all kind of taxes out there. You'd be surprised how much we get taxed. Okay, a lot of people don't really stop and think about how much we get taxed. If you actually thought about how much we were getting taxed, then taxes will become like a primary focal point of your existence when it comes down to voting and dealing with politicians and making decisions. Okay, there's income tax, there's sales tax, there's property tax, there's uh, what is the other one? There's estate tax. They even tax you when you die. Um, there's one more I can't call it now. Though yeah, there's road tax because you got fuel tax. Okay, and then if you buy cigarettes and stuff, there's cigarette tax too. So yeah, so there's a lot of items that are just taxed. Like when we go purchase gas, a lot of people think that all you're paying for is the gas. You're not. A big part of your gas cost is federal taxes. They take and charge you money, taxes on the gas to fix up the federal highways and stuff. Okay, and then there's another one I forgot too. There's Social Security tax and then there's Medicare tax. Okay, Medicare and Social Security are two different things. Okay, Medicare is to pay for your insurance when you get older, which the government provides. And then Social Security is to pay for your retirement, which the government provides. Okay, so that's all the taxes. Okay, there's other taxes, but I didn't call them all out. Okay, so here we go. This one's dealing with income tax. Okay, that's something that everybody has to pay if they're earning money. Okay, this is a single person and they have taxable income of 30,000. Now it's important to identify that it's a single person because single people, married people, people that have children who are considered head of the household have different tax rates or what we call different tax brackets. So a single person has the highest tax bracket. So that's why that's important. Okay, taxable income of 30,000. So we're going to go to their tax schedule. Notice at the top it says single taxpayer, and this is probably a 1040 EZ because they got 1040 EZ, 1040A, and 1040. Okay, 1040 EZ is when you don't have a whole bunch of other items. But if you've got like other items like charitable contributions, mortgage interest, property taxes, medical costs, then you'll file a 1040. Okay, if you've got like a moderate amount, like if you got like other transactions like retirement and stuff, you could probably get away with 1040A. Um, so here we're gonna look at 30,000. Okay, now if you look at 30,000, we got tax brackets. Okay, so 30,000 is gonna be right in here. Okay, that's their bracket right there. That's why it's called a bracket. Okay, so for the first 28,400, okay, this is what their taxes are gonna be. 3,960. Then anything above that 28,400, they'll pay 27%. So that 27% is based on 30,000 minus 28,400. which you end up with 1,600. So they're gonna pay 20. They're gonna pay 27% on 1,600, and then you'll add the 1,600 with the 3,960, and that'll give you their taxes. Okay. And so when we add the two together, we come up with $4,392. Okay. Now our tax system is a progressive system. It's not a flat rate. So, the more money you make, the higher your tax rate goes. I think it progresses all the way up to like 39% or something like that. But if you look at that right there, if we were to say, well, okay, well, what is the real rate? What are they really paying? We would take the 4,392 divided by 3,000, 30,000. So their real rate is like almost 15%. So that's really what they're paying, when you look at the real rate. All right, another form of taxes is property tax. Okay, so if you own property, you pay property tax. If the tax is increased by 18%, what is the new tax for landfill? Now that 18%, we know that. We've seen an increase of 24% on the project. Okay, so 18% is going to increase the same way. So we got to figure out what the base is first. Okay, so here we go. They're going to provide us with the landfill here. And so there's landfill. It's going to be 1461. Okay, so then we're going to take the 1461, multiply it by 18%, and add it to the 1461. Or we could do what we did earlier, which is 1461 times 1.18. So we could do it that way too. Okay. Okay. All right, here's another type of taxes we'll see is sales tax. Okay. We got some transactions here. Two large Kit Kats at $1.59 each. Two sandwiches at $2.99. Okay, and the sales tax rate is 7%. Okay, not everything's taxed for sales tax. Okay, if it's processed, you got sales tax on it. Okay, so here we'll add up all the costs. 960. Then we're gonna multiply it by 7%. Okay, and then that's gonna be our tax, 64 cents. And then we'll add the two together, 980. Now another way we could do that is we could take that $9.16 and multiply it by 1.07, like that. Because adding that one to it allows us to account for the addition of the $9.16 to the sales tax amount. So if we do it this way, we'll come up with the same answer. This way it's just faster. Because remember, multiplication is addition on steroids. Okay, it's bigger, faster, stronger. All right, monetary conversions. Now we talked about conversion rates earlier. Okay, and you see conversions a lot. Okay, so that's a central theme in math. Okay, just like base times rate equals amount, rates are a central theme. Conversion rates are also a central theme. Okay, so it says in 2004 the value of a $1.83 was 1 British pound. So our conversion rate here is 1.83 because we can see that we got 1 unit being compared to 1.83. So we're going to either multiply by 1.83 or we're going to divide by 1.83 depending on which way we're converting because we got our rate. They gave it to us. Okay, so this is our rate right here, 1.83. Okay. Okay, so now we want to convert 5 British pounds to a dollar. Okay, so the way we're going to do that, okay, in this case, we're going to multiply by 1.83. Okay, and then that'll give us 9.15. And it says convert $5 to a British pound. So we got $5. We're going to divide that by 1.83. And that's going to give us 2.73 British pounds. But the conversion rates, they're real easy if you just can remember what your conversion rate is. And then to know that to convert from one unit to the next, you'll either end up multiplying by that conversion rate or dividing by that conversion rate, because that's the central theme behind conversion rates. Okay, you're going to either multiply it by it or divide. Now, the way you can determine whether you're going to multiply or divide, like if I'm going from dollars to pounds, what I do is I just look at it in terms of language. I say, okay, if I'm going to go from a dollar 183 to 1, I went down. So I say I went small. So in order to go small, division makes things smaller. That's the way it works. Division makes things smaller. Now, if I go from British pounds to dollars the other way, I say I went big. Okay. Multiplication makes things bigger. And so that's the way I remember it. Okay. So if I'm going from pounds to dollars, I'm going big. Okay. Big in terms of, the quantity, not the value, because the values are the same. So I went big. I went from 1 to 1.83. And 1.83 is bigger than 1. So I went big. And so to go big, I always multiply. And to go from 1.83 to 1, I went small. And so to go small, I divide. Okay. And all I have to remember at that point is just my conversion rate. If I'm going small, I divide my conversion rate. If I'm going big, I multiply my conversion rate. And that's it. Okay. Uh, One of the things that helps people better understand math is when you can make common sense of it. We have things called mnemonics, like please excuse my dear Aunt Sally and King Henry died while drinking chocolate milk on Monday. Those are common sense ways of remembering math rules. They just stick better when you've got a way. Like with my conversion rates, if I go small, I divide the conversion rate. If I go big, I multiply the conversion rate. And I can look at the numbers and tell whether I'm going big or whether I'm going small. All right, here's stocks. I got a really cool video on stocks. I'm gonna send you guys the link. It's that baby commercial. Ooh, let me see if I can get to it from here. We're not gonna watch it. I'll let you guys watch it on some other occasion. Oh, no fair. Let me exit. Let me see. Okay, so we're not gonna do that because we're running out of time. Where's it at? Here we go. I'll send you guys the link to it. That's what I'm trying to do now is get that link for you. It's a really good. It's funny. Everybody needs to laugh. Okay, so I sent that to you. You can watch it at your own leisure. Good video. Okay, back to the grind. We got about 30 minutes together. You can pull these PowerPoints from the resource tab in your online classes. Okay. Here we're talking about budgets. Budgets are very important because a budget is just a financial plan. That's it. There's a cliche that says, by failing the plan, we plan on failing. So you want to have a game plan. Okay, if you like sports, you know that teams have game plans. A way to win is what a plan is. And so that's what a budget is. It's just a financial plan. It's a way to win financially. Okay, so in a budget, we've got planned expenses and planned income. In other words, there's no surprises. We know what's going to come in and we know what's going to go out. Okay, and that's going to help us make better decisions. Okay, Income is what's coming in. Expenses is what's going out, what you're paying out. And savings is what is the difference between what went out and what came in. Okay, we have debt. Debt is money that you owe somebody else. Okay, so let's look at debt. Now there's a saying in America, you can't build wealth without credit because you have to finance and you have to borrow. Almost all of the large ticket items in your life are going to come down to you borrowing. Okay, you can't have a house unless you borrow money. Okay, not going to get a car unless you borrow money. Okay, most of the times you can't afford education or a degree unless you get student loans. So almost all of the important decisions in your life are going to involve loans. Okay, and so if it's going to involve loans, then you're going to get charged money to borrow that money. So you need to really know you know what you're getting charged for that. Okay. So what the finance charges are for a loan, we call that the interest rate. The amount that you're borrowing, we call that the principal. The term is the period of time in which the loan must be repaid. Monthly installments is the amount you pay each month. Okay, so here's a situation about a loan. A $1,000 loan with a 6% interest rate is to be repaid in 12 months. If the monthly payment for this loan is $86.07, you can calculate the following after each month. Okay, so we'll find the interest by multiplying the loan balance by the rate, the annual rate divided by 12. And there's a difference between the effective rate and the annual rate. Okay, and then we have principal reduction, remaining balance. Okay, is what's left after you reduce the principal. Okay, so this is what's called an amortization schedule. You'll see this when you go get a car or you get mortgage or you get a mortgage or something like that. You'll get an amortization schedule. They'll basically break down, you know, how much you borrowed, how your principal or how much your loan is reducing uh, each month, how much you're paying for interest, and how much is going toward the principal or the debt itself. Okay, so this is the schedule right here that we see. Okay, in that first month, we pay $5 for interest. The remaining $81.07 goes toward a loan repayment. And if you add those two together, the $5 and $81.07, that's going to be your total payment. Okay. Now, the interest is all calculated by taking 6%, dividing it by 12 because it's 12 months in a year, and then multiplying that by 1,000. Obviously, 6 divided by 12 is 1/2 a point, you know, uh, 0.05, and then you take that 0.05 multiplied by 1,000 to come up with $5. Okay. Another type of debt we'll see is credit card debt. Okay, credit card debt is something serious. Okay, most people know what credit cards are. Okay, the interest rate for anything except for student loans with mortgages, car payments, or credit cards is based on credit risk. Okay, so if the finance companies don't think that you're gonna be a good candidate to pay their money back, they one will not loan you money, or two, if they do loan you money, it's gonna loan you at a higher interest rate. Okay, there's finance charges, which is what you have to pay for borrowing the money, and then with the credit cards, they also have a daily periodic rate. Okay, that's the interest that's been charged on the outstanding balance. And then we have an APR, which is the annual percentage rate. Okay. Other factors that we look at are credit score. Okay, these are all your credit score factors. Okay, credit score is not just based upon what you pay or don't pay, It's based upon your payment history, how much you owe, the length of your credit, new credit, meaning how much credit you go out there and get, and other factors. Okay, so these are the breakdown of what impacts your credit score. Okay, so a person who doesn't pay their bills back on time, but they have been borrowing money for a long time, will have a reasonably better credit score than somebody that's just not paying back stuff on time. Okay, so here's a credit card situation. We've got a monthly rate of 1.5%. We have an APR of 18%, and we have previous balance of $400. And then we have payments of 300, and then we're going to purchase something for $50. And now what we want to do is figure out what our average daily balance is so we can figure out what the finance charges are because they're based upon the average daily balance. Okay, so the way we do that is the balance changes. Okay, the first 15 days it was $400. Okay, then the next 3 days it was 100 because you made a $300 payment. Okay, then it went back up to 150 because we went out and bought something new for 12 months. Okay, then all that gets divided by 30 because that's the total amount of time. Okay, and so we're going to always divide it by something to find the average, just like we did with the average salary and also with average grades. You'll always divide it by a total. And so what we're saying is there's a total of 30 days in the month. Okay, so the finance charges is going to be based upon the average balance of $270 multiplied by the monthly rate of 1.5%, and that will give us a $4.05 finance charge. Okay, and here's how that kind of breaks out. If we had a 30-day billing cycle and we had a credit card where we started off with $875. Okay, and then we paid off 300, then we went out and spent 400 more, then we went out and spent another 600. Okay, so we can see our number of days, 1 day, 7 days, and then 21 days at the 1575. Okay, we're always going to treat it like it's a 30-day cycle. And then from there, we'll do our multiplication, divide that by 30. And then that's going to give us an average daily balance of $1,378.33. And then we'll multiply that by the monthly rate to get our finance charges. And then that's going to give us $13.78 for our finance charges. Okay. Okay, we got about 20 minutes here, so we're going to skip this credit card because we've already looked at it. And we'll get to mortgages because that's another important debt that we'll see in life. Here we have a mortgage, a 15-year mortgage. It's $300,000 borrowed. So that's going to be a nice house for that amount. And the monthly payments are going to be based on 5%. Okay, so we'll calculate based upon our mortgage rates. Okay, here's our interest rates for 30-year factors and 15-year factors. Okay, from there, we're going to find the monthly payment. So we'll take our rate of 7.91 for a 15-year factor. We're going to multiply that by 300,000 divided by 1,000. And then that'll give us a monthly payment of $2,373. Now we want to know how much is the total interest of the above mortgage. Okay, so if we take 15 multiplied by 12, because it's 12 months in a year for 15 years, I multiply that by 2,373 because that's what our payment is each month. that's going to give us $427,140 for our total interest of the above mortgage. And then we'll take that amount and subtract it from the 300,000 that we borrowed. And so our total interest is going to be $127,140. Okay, so here we're going to make a table showing the first 12 months of an interest and repayment for a mortgage of $50,000 over 10 years. The mortgage rate is 10%, and you have to pay $660.75 every month. Okay, so to figure out what our monthly rate is, we'll take 10% divided by 12. And here's our amortization schedule here, where we're simply multiplying the principal by the monthly rate of 0.00833. It's going to give us our interest and our loan repayment. The loan repayment is the principal. Okay, those two things together will equal the interest, and the loan repayment will equal the monthly payments. Okay, and so we can see after 1 year what we'll owe looking at this amortization schedule. Okay, so we can see that $4,862 went into interest, $3,067 went into paying off the $50,000. Okay, so we're going to find a good place to stop here with the lecture. We got about 18 minutes. And with those 18 minutes, I'm going to field any questions about anything that's going on with Alex. Okay, so are there any questions about Alex or the project that's coming due in the next day or two? Okay, Randy, what's your question? Oh, okay, do we use the graphs that were supplied or make the four graphs that are supplied? You have to do those four graphs, but then you're going to have to make up your own graph to show that your business is profitable. So what I'm going to do is I'll show you one. I'll show you how I would do it. Give me a second. I'm going to pull up another application. But that's definitely a good question because a lot of people they'll either do the four graphs and ignore that last graph. They won't have a graph in their project, or they'll do the project with a graph and they won't have a graph. They won't do the other four graphs. So they normally do one or the other. They don't do both. And then sometimes people just don't know how to do um, that last graph. I'm going to pull up a program that allow me to call Sketchpad if I can find it. Oh, I'm getting old. All right, so here we go. Okay, so this is what I'm going to do. I'm going to create a graph, but the way I'm going to do it is I'm going to create a revenue function and a cost function because that's basically what it is. Okay, and then I'm going to show a break-even point. So it'll say this is what I'm going to break even. And I mean, I can do it a lot of different ways, but let's see if I got a studio and I'm going to do it, say based upon time. So I'm going to say that with my studio, that I'm going to rent it out every month, and that for each month I'm going to make, I don't know, I'm going to say 6,500. And then that's going to be that right there. Okay. So Y equals the money. X equals the months. Okay. Okay, months. Okay, so that's the way I'm gonna do it. So X is gonna equal the months, Y is gonna equal the dollars. Now that's for my revenue. So this first one is what I call a revenue function. I'm gonna make $6,500 for each month. Okay, and so for 12 months, I'll see how much I have for 5 months, so on and so forth. Okay, yeah. So, well, maybe I should make that 165,000. I'm gonna pretend like I'm gonna make a lot of money. Okay, so I call this one a revenue function. It's revenue or sales, whichever one you're comfortable with. The other one's gonna be a cost function or an expense function. Okay, so with my expenses, I'm gonna say, well, let's see. I'm gonna each month for like lights and my water bill and if I've got salaries to pay and all that stuff, I'm gonna say that's gonna cost me 4,000. Well, let's see. I don't want it to be too much because I say if I say 40,000, that'll give me 480,000. Yeah, I'm gonna say 40,000. That's a good enough number. 40,000 like that. Plus, I got some fixed expenses. Okay, so I'm paying out about 40,000. Well, I got 16,000 there, so I can't be 40,000. That's got to be 4,000 then. Okay, you know, because if it was gonna be 40,000, then I wouldn't be charging 16,000 a month. I mean, I wouldn't choose to make a loss. So I'm gonna say 4,000 that I'm going to my monthly bills are gonna be. Plus, I'm going to have some fixed costs. Okay, now what are fixed costs? Fixed costs are things that, I went out and bought equipment and stuff. I went out and paid for a building that movie studio, that movie set, or that music studio that I was building, that costs money. Okay, and so if I don't make $1, I still got to pay for that. So I'm gonna put that at, let's say, for instance, 16 there. I'll say it costs. It's a building, so I'm gonna say I spent 300. What I did in the mortgage. Okay. So those are my functions right there. I've got 16,500 at X, and then I've got Y equals 4,000 X plus 300,000. Okay. Now I got to graph those and show my break-even point. Okay. I'm gonna use a program that I use all the time. It's called Desmos, and then that way I can just plug them in without having to do all the math. Okay. It's sort of like a graphing calculator, lunch calculator. All right. So my first function I said was going to be y equals 16,500 x. So that's that first one. All right. Where's it at? Okay. I'm shrinking my graph so I can put all my numbers in. All right. Minimize that. All right, why isn't it going? And then my second one, what did I say? Y equals 4,000. Are these like supposed to be functions or something? X plus sketchpad 300,000. Okay, now that's supposed to be lighting up. Okay, now that's supposed to graph. All right, let's do this. For some reason it's not responding. Okay. Let's try it now. Here we go. Okay, so the first one was 16,500. X add shrink. Now let's do this. Okay, it should be going y equals that's that one. Yeah, but that still should be going up like that. 4,000. Well, let me do this then. I'm going to convert these to decimals, shrink the values of them, pretend like it's every 0.5, like that. All right, that'll work. And then I'm going to make that one like 4x plus 300,000. So I'm taking it every 1,000, so I think that's going to be 30. All right, so there we go. Okay, so that should do it right there. Okay, what I basically did was multiply or divide everything by 1,000, and at the at the bottom of my graph, I'll just say that each one unit is equivalent to 1,000. So 1,000 times 16.5 will give me 16,500. 1,000 times 4 would give me 4,000, and then that's going to be 3. All right, so there we go. So let's see. Okay, and so here I can see my break-even point. Okay, my break-even point is right there at 24 and 396. Okay, so that kind of, so I mean, you could use a tool like that, Randy, and then graph it onto graphing paper once you figured out where it breaks even at. Okay, and then that's how I show profitability. And then of course if I scroll across it, it's going to tell me that, at 24 months. So that means that, it would uh, take 2 years, which there's not 2 years in a year. So that wouldn't really work. I would either have to increase my revenue or find a way to cut my cost. If I was able to maybe cut my cost down some, let's see, I could get it down lower than that. Let's say if I cut my cost to 145, and then if I looked at it from there, okay, let me cut it down to like 130, 120, 125 and see what happens. There we go. Okay, so at 125, if I could cut my cost to 125,000 in 10 months, I could break even. Okay, so in 10 months. Now I would either have to cut the cost to 125 from 300,000, or my revenue would have to go up higher than what it is. I would have to, make more than 16,500 like that in order for it to work. Okay, if my overhead was 300,000 and my variable expenses were 4,000, well, that's a lot of overhead. Okay, Randy. So that's how you would solve that type of problem. You would use a graph like this to show your break-even point. Anything above the break-even point would be profit. Do you have any other questions? You'll be able to access the archive. What I'll do is when I close it down, I'm gonna need to I'm gonna need to back up the archive first, and then everybody that registered for this go to training, they'll get access to the archive. Okay, so it'll come to you in an email. All righty, good deal. All right, so if you don't have any more questions, we're gonna go ahead and close out the go to training because it's 3:58, and then I'll spend the remainder of the time backing up the go to training recording uh, for um, for the archive version. Okay, and thank you too, Randy, and have a good afternoon. Oh, where we go from here?